just reviewing how to use either substitution or elimination. I'm going to use substitution. We'll be able to solve all of our systems in geometry using substitution, so we'll keep that consistent. So when we're dealing with any type of parallelogram, so a parallelogram, then any square, rectangle, rhombus, which are also still parallelograms, the diagonals are going to bisect each other. That means that whenever you draw from corner to corner, they're going to meet at a center, and then they're going to split into equivalent segments. So the two that I marked with one tick mark, those are congruent. The two I marked with two tick marks, those are also congruent. So that means that their expressions are equal to each other. So 2x is going to equal 2y plus 2. So there's the first equation that I could set up. And then secondly, 2y is equal to x plus 9. So there's my two equations that I'm going to set up. Now what I would look for is do either of those two equations have all the same variable? Because I want to try to get an equation where all the variables are the same. I don't have where all the variables are the same, so I have to use a system of equations method to solve this. Now, when you're using substitution, what you're looking for is in either of my two equations, do I have anywhere where there's just a single variable? So here's where I just have a single variable x. And what you want to do is you want to solve for that single variable, so you get an expression equivalent to a variable. So what I'm going to do then is I'm going to use algebra to subtract 9 over to the other side. Now I've made a new equation. I've got x is equivalent to 2y minus 9. So there's an equivalent equation to the one that I set up. I just subtracted the 9 over. Now I know x is equal to that. So this I don't really need anymore. That one is no longer useful for me. But now I know that x is equal to 2y minus 9. So I can take this 2y minus 9 and I can now substitute it in for wherever I see an x, which is right there. And what that's going to do then is that's going to replace the x out. It's going to put the 2y minus 9 in, and now I have an equation that's going to have all y's. So here's what it would look like with all of my y's. So now I have a 2. The x comes out. I'm replacing it with 2y minus 9, and since it's a binomial, there's two terms in it. I got to group it together to include it all in one group, is equal to 2y plus 2. Use the distributive property. I'll get 4y minus 18 equals 2y plus 2. And then we'll do our last steps of algebra. I'll subtract the 2y over, which is going to make 2y. I'll add 18 over, which is going to make 20. So I'll get y is equal to 10. That's half the problem. So now I know y is equal to 10. I can go back and then find out what x is. And this equation right here would be the best to use because x is equal to 2y minus 9. So I'll just put a 10 in for that y. 2 times 10 is 20, minus 9 is 11. So x is going to equal 11. So you can express your answer, y equals 10, x equals 11. Also, that would be an ordered pair. X is 11, y is 10. There would be our answer. So you can express your answer either way. I will accept either. So this type of problem, we set up two equations that had two variables. We couldn't get an equation that had all one variable, so we had to use that substitution method. And that's a review of topics that you've seen in Algebra 1. And we're now starting to relate those topics into geometry. So there were 3 of those to practice on section 6.3. And just letting you know, there will be one of those on your quiz tomorrow. So one where you can set up your system of equations and you will be able to use substitution. That'll be what you can use. If you have any questions, you can throw them into the comments on this one. If there's anything that you want clarified on this problem, you can turn on your mic, let me know, or throw it into the comments, let me know. Are we good to move on to another one that will be similar to the quiz tomorrow? All right. We'll head into our review. So our review, yesterday we kind of started and some of you stuck around. We did a couple problems together today. Want to just focus in on a couple things with rhombuses. So this is going to be for the section from 28 to 31. So I will give you a second if you want to take out a sheet of paper, or if you have this open, you can take a look. So while you're doing that, the properties of rhombuses that we're going to use, the big one is that in a rhombus, in rhombuses only, not parallelograms, but your diagonals are going to make 90-degree angles. So that's the big one. So anytime you have a rhombus, if it tells us it's a rhombus, like up in the directions up here, and then they have these intersecting lines, or the diagonals, we automatically know that those are going to be 90. So they don't need to mark it. That's just something that now we can tell without markings. If there is a rhombus, the diagonals are going to make 90-degree angles. The next thing about a rhombus is the opposite angles are all congruent. So those two angles are congruent to those two angles. So all four of these angles are going to be congruent, and then all four of these angles are going to be congruent. So those opposite angles, the theorem says those opposite angles are bisected, which is going to make two sets of four angles that are all congruent. So back in section 6.4, which we started introducing rhombuses, we started talking about these angles. The opposite angles in a rhombus are bisected, and then those angles are also equal. So you got sets of four angles that are going to be equal in a rhombus. And then we can start finding missing angles in rhombuses based on given very, very minimal amounts of information. We can tell all the angles in a rhombus. So looking at this first example, I've got four angles I'm going to find. I'm just going to look at number 30. So we've got an angle 1. We've got an angle 2, all the way up to 3 and 4. So an example like this on the quiz tomorrow would be worth 4 points. So you can get up to 4 points. You can get partial credit, however many that you get correct. So first, when you're starting to find these missing angles, you do not need to go in order. So if you can find an angle, you can find that angle first. So here, angle 1, I cannot find angle 1 until I know what angle 2 is, because I need to know how many degrees angle 2 is in order to figure out how many degrees that angle 1 is. So angle 2, since it's where those diagonals are intersecting, that's going to be 90 degrees. So 90 degrees is going to be where angle 2 is. Now I can go up and look at angle 1. So if angle 2 is 90, this angle up here is 20 right here. I've so far got 110 degrees taken up in a triangle. And I got to think how many degrees are in a triangle, because that's really what figure I'm working with, that those diagonals split it up into triangles. I've got 110 degrees taken up between 90 and this 20-degree angle. Well, how many are left to make 180 total degrees? 70. So that angle is going to be 70. Now, the other property that we talked about was these opposite angles are going to be bisected, and then they're also going to be congruent. So right here in this set, I've already found this one is 70. Well, that means that this one over here is going to be 70, and then also 3 and 4 are both going to be 70. Since they're on that same diagonal as the 70-degree angle I just found, those would also be 70 degrees. So I found all four angles. You're going to use properties of triangles, because triangles add up to 180 degrees, and you're going to be splitting into triangles. Like this example up here, you're splitting into triangles. And then also using properties of rhombus, that the diagonals make 90 degrees. And then lastly, that those opposite angles are going to be bisecting each other. So those are two examples. So looking at how to use substitution, so a little review from Algebra 1. There were two more examples similar to that on section 6.3, but you don't really see a problem like that in the review. So that's why I wanted to just revisit that. We had done one before break, but now we've done two of those. But if you want to stick around and do any of those other ones with the substitution or anything else with finding angles and rhombuses, parallelograms, you can stick around. So it is 8:30, and you can break off to continue your review. I'll be on the call until 8:55 if you have questions, but tomorrow we will have our Chapter 6 quiz. If you want to stick around to ask questions, or if you want to just jump on and off, you can go ahead and do that. But everything that we just did here was recorded, and I will be posting it to our class page.